For this video, we've totally given up on entertainment value. So instead we'll be doing it the good old-fashioned way. Armor style. Now let's look at an example of non-uniform circular motion. Let's say we had an object of a certain mass and attach it to the end of a string. The other end of the string is fixed, it won't move. What we've just created there is called a pendulum.
A pendulum is a suspended weight hanging freely. In this instance, because of the horizontal applied force, the skull will not move. The skull is, let's say, raised 30 degrees from the equilibrium position, and the other force acting upon it is the force of gravity. To calculate the tension of the rod holding the skull, it is the force of gravity, mg, divided by cosine 30 degrees.
To make a turn, you need friction. Without it, your car tires will be confused, and your car will consequently look like me during a physics test.
By Newton's first law of inertia, my body wants to go in a straight line, but the car exerts a force on me as it turns rapidly, causing me to also change velocity. What I'm experiencing right now is what some call the centrifugal force. The side of the car door is the centripetal force. While it may seem like my body is pushing against the car door is actually pushing against me. Therefore, the centrifugal force technically doesn't exist.
Before we can calculate centripetal force, we first need to be able to calculate the object's centripetal acceleration. If the object is traveling at 16.67 meters per second with a radius of 3 meters, the centripetal acceleration can be calculated to be 92.6 meters per second squared. Therefore, given the mass of the object being 1200 kilograms, we can then calculate the centripetal force.
This is the force required to keep the object on a circular path. If this force were to be greater than the other forces acting on the object, which in this case is friction, then the object would fly off its path. This is what happens in non-uniform circular motion.
Here we have a record player, which is spinning at a constant rate. If we were to place an object on it, we would see that the object would follow a circular path.
And while it may look simple, there's actually a lot happening to the object. When an object is moving in a circle, there are different forces being acted on it. One of them is called centripetal force. In order to find the centripetal force, we use this formula, where Fc is the centripetal force, m is the mass of the object, and ac is the centripetal acceleration. Centripetal acceleration is the object's acceleration towards the center of the circle. We use this formula, where v is the velocity of the object and r is the radius of the object's circular path. Before we can calculate centripetal force, we first need to calculate the centripetal acceleration of the object. If the object is traveling at 1.23 meters per second and the radius of its path is 0.15 meters, the centripetal acceleration of the object is 10 meters per second squared. And given that the mass of the object is 0.15 kilograms, we can calculate that the centripetal force acting on the object is 10 newtons. This is the amount of force required to keep the object on the circular path. If this force is greater than the other forces on this object, which in this case is the frictional force, then the object will fly off the platform. This is what happens in non-uniform circular motion. How we calculated the centripetal force of Minimar on the record player. The speed of the record player is based off of rotations per minute. From the two equations earlier, we can rewrite the formula for centripetal force as F equals mv squared divided by r. From this, we can see that as the speed of the object increases, the centripetal force also increases.
And as always, thanks for watching.